finally, let me briefly say something about the complexity of computational tasks. Because we have talked about the number of bits, and this is sort of the capacity of the information that you have, and the number of possible ways to process it, which was a very large number indeed, but we could break it down into smaller operations. And then we should also ask how many of these operations do we actually need in order to complete our task. And we are going to denote this number simply as t. And now there are certain classes of problems in which we can make predictions of how many steps this will take. In particular, there are many relevant computational tasks in which the number of steps increases as the power of the number of bits that you need to process. So the number of steps is of the order n to the p, and this class we call capital P, the problems that we can solve in so-called polynomial time. Now there is another class of important problems in which the number of steps increases exponentially in n, so as a to some power n, which is generally a much larger number if n is a large number as well. Now this turns out to be a very rich class of computational problems which has many subclasses. And in there is one which is particularly interesting. That's the class in which it indeed takes a long time, many steps to solve the problem. But once we have the solution, we can use algorithms which are polynomial in time to check that our solution is indeed true. And this class of problem we call NP, where the N stands for non-deterministic. And the probably most important example of this is prime number factorization. Where we start from some integer n and set out to write it in terms of its prime factors. Now finding these prime factors takes a long time if the number n has many bits or digits. Indeed, the best algorithms that we have take an exponentially long time. However, once we know these prime factors, we just need to multiply them to each other, and then we can check whether we get the correct number, and this can be done very quickly. Now, this is a practically important problem because much of the encryption of data on the internet relies on the fact that prime number factorization is hard. But as it happens, a quantum computer would be able to speed up this process significantly. So let us now turn to the details of quantum information processing.